through today. First of all, happy Valentine's Day. Woohoo! um, yeah, pretty exciting, I guess. Okay, so today we have a lot of different topics that we're going to be covering. Our first one, sorry, scrolling down here. First one, we're going to go through quadrilaterals. And I know a lot of this is going to be review for you, so we won't spend too much time on that. But then we'll go into congruent figures versus similar figures. And we'll do some practice. And then I think this part's the best part. We'll go into transformations. That's those slides and flips and turns and those kind of things. So, all right, let's go ahead and start up here and just review the different types of quadrilaterals. Now, I know it's been a few weeks since we talked about this, but does anybody remember what quad stands for whenever you see that prefix quad? Go ahead, Nicholas.
Four.
Yeah, and Jacob just put it in the chat as well. So that means four. So you're going to have four sides, four angles, or whatever the case is. So any four-sided shape is called a quadrilateral, and it has to be two-dimensional. This is two-dimensional. We're not talking about cubes or anything three-dimensional. Just two-dimensional. And okay, so let's just take a look at some pictures. I just wanted to scroll down here. Okay. So lots of different types of quadrilaterals. A parallelogram. What is this word? And this is another like prefix. What does parallel mean? All right, Nicholas, go for it.
It means that two lines are exactly away from each other. They will never intersect or get
Yes,
farther away from each other.
exactly. It means these lines are exactly parallel. They will never intersect. So you can see this red line and this red line right here are both parallel. They can go on forever. So that's a parallelogram. It has two sets of those parallel lines. And of course, it's four sides and four angles. A rectangle, I mean, that's pretty easy. I'm sure you all know what a rectangle is. Been dealing with those for quite some time. A rhombus. Now, what does a rhombus kind of look like? Sierra?
It kind of looks like a diamond.
Yeah, it kind of looks like a
Sort of.
diamond. Exactly. So, what you can notice about a rhombus is look at this angle, and those are the same. And then this angle and the one right across from it is the same. So, it has not all four are the same, but at least two of them are. Okay. A square, well, that's pretty easy as well. Square means all four sides are the exact same length and angle. Okay, trapezoids, they're a little bit different looking. Trapezoids definitely don't have parallel lines. Well,
They
actually,
have
it looks like
one set of parallel lines.
it has
They got
one set. That's
One
right.
parallelogram because it only has one set. A
That's right.
parallelogram has to have four or two sets of parallel lines.
That's right. Yes, exactly. So, definitely different sizes too of those lines. And then, of course, a kite. Okay, so we'll just kind of keep that in mind if we need to come back to these different pictures while we play our games. All right, let's take a look here. We are going to be just doing a quick little practice now that we've had a review. And we're going to practice classifying them. So, like I said, just telling me what type of quadrilateral we're looking at here. Go ahead and type into the chat which answer you think. You could just look at it as A, B, C, and then D to make it a little easier. Okay, good. Good. I'm saying most people are saying that this is a rhombus. Let's check it out. Yay! All right, what kind of polygon or quadrilateral are we looking at here? We have a trapezoid, a square, a parallelogram, or a rectangle. Ooh, good. Awesome. Most people are saying rectangle, and that is exactly right. Why is it not a parallelogram? Nicholas?
Um, because a parallelogram has a sort of like tilted in a way, so it's not a rectangle at all. A parallelogram, it it has two sets of parallel lines, but it's not a parallelogram because a parallelogram sort of tilts it,
Kind
so
of
it gets to
tilts.
appear
Well,
deformed.
yeah.
But
See, well, if you look at this picture though, can you see that these lines are kind of tilting? They're not, this was kind of a hard one. Um, a rectangle, think of it as more of like a perfect straight up and down and perfect straight across. These lines actually are slanted. So that was kind of hard. It's a quadrilateral with both pairs of opposite sides that are parallel and congruent. And you can tell by these lines, that's what those little red marks mean, is that this line and this line are parallel, and then this line and this line are parallel. And yes, it does have a slant to it. So that was tough. It's okay though, because that was tricky. Now, what are we looking at? Most of you said this for the last one. Very good. Now we're looking at a rectangle. And do you know that the difference here is in the rectangle, these angles are 90-degree angles in the corners. So that's what makes it that rectangle. Okay, so those are kind of hard, distinguishing between parallelograms and rectangles. Now this one's pretty easy. What are we looking at here? We only have two sets of parallel lines. That's it. Very good. It's a trapezoid. Everybody got that one correct? Okay, let's do maybe, oh wow. I don't think you guys have even gotten into isosceles trapezoids, but that's okay. Isosceles, does anybody know what that word means? It can also apply to different triangles. Isosceles means, okay, go ahead, Nicholas.
um, I, it means there's two lines that are the same length,
Okay, so
and then one
that's
line. And
in
for
one line
triangles,
that's,
that I think what it means,
well, I mean,
where it has
that's
two
okay.
lines.
Jacob,
It's
what do
like
you think? Jacob's typing into the chat right now because he also
hey,
thinks that he knows. Although, while we're waiting for him, I will just tell you that yes, it has at least two sides that are equal. Now, the rest of the sides are definitely not. So,
It looks like a
oh,
kite.
it does look like a kite. All right, so this is actually, they're telling us, isn't, okay, what did they say it is? A quadrilateral. So I guess the best answer for this one's a quadrilateral because it has four different sides. Isosceles trapezoid is a quadrilateral with one pair of parallel sides and one pair of congruent non-parallel sides. Okay, okay, so that's what makes this not a trapezoid. Triangles are a
yeah,
little different. If I cut it off like right there and just made a triangle, this would be a good isosceles triangle. All right. Let's go ahead and play a quick game and then we'll move on. All right. Quadrilateral quest. You know their properties. I'm sure you do. Okay, here we go. All right. So I'm going to have you just type into the chat which one you want me to do. Let's see. And I have which shapes below have all of these properties. So they have to have all of the properties. Opposite sides are congruent. Opposite sides are also parallel. Opposite angles are congruent. Okay. All right. Yeah, I'll just call. How about this? I'll just call on you, and you guys can tell me at least one of them to drag and drop. Autumn, tell me one of them.
The rectangle.
Okay. So you want me to this one right here?
Yeah.
Okay. Very good. Nicholas, is there another example that has both congruent sides, opposite sides are both are parallel, and opposite angles are congruent?
The parallelogram above the trapezoid.
This thing right here?
No, the one above that. A
This one?
trapezoid. Yeah.
Okay. Very nice. All right, Sierra, what do you think?
The square.
The square. Okay.
I don't see a square.
All right, very good. Any other shapes here? Ooh. Lucas.
The thing next to the shape, I don't know, weird shape. Looks kind of like a car.
So this one?
But no, the up a little. No, next to it. Yeah, right there.
Okay. So yeah, that's just a parallelogram. Yep. Very good. Sierra, there's another one.
The diamond.
The diamond. Mm-hmm. Good job. We've done all of them. All right. Now it's going to give us a new set of properties. Okay. Now we are looking for shapes that have four sides and only two parallel sides. Okay, Nicholas, tell me one of them.
Um, right, right here. The one, yeah.
Okay. Very nice. Okay, Sierra, tell me another one.
The trapezoid looking one.
The trapezoid, right, because it has four sides and only two of them are parallel. Very nice. Okay.
Two trapezoids.
Yep, there were the two trapezoids. That's right. Okay, it's going to get a little harder. We are looking for shapes with four sides. All of the sides are congruent. Opposite sides are parallel. And all angles are right angles. Ooh. Lucas, tell me one of them.
Square.
Okay, very nice. Actually, this one is a little easier because of this last requirement. Go ahead, Sierra.
The rectangle.
Okay. Oh, I was a little hesitant on that one. Why is this one not going to meet these different properties?
Because they're not all equal sides.
Yeah, that's right. All of the sides had to be congruent. So, okay, Nicholas is going to burst. Tell me, Nicholas.
That rhombus. It's like a sideways square. That rhombus in particular.
This one?
No, the one right next to that. No, a little, right in the middle.
Okay, so that's a diamond.
Right there. Yeah.
Yeah, okay.
Like sideways square.
Yeah, Jacob's been feverishly typing diamond into the chat. That's what that's called. Very good. So notice this was the property that kind of threw us off, that they all had to have right angles and all sides were congruent. All right, now we're getting a little harder. Has four sides. All right, well, that's easy. But has two pairs of congruent adjacent sides. Congruent means the exact same, right? Now, adjacent, have we heard that word? Nicholas, go ahead.
They're right next to each other. They're not like, they would be right next to each other.
That's right next to each other. So they share an end point, right? Okay, so Nicholas, which shape can I drag and drop?
The square down way at the bottom next to the top.
Okay. Very nice. Okay, let's take Sierra.
The diamond.
Okay. And it looks like there might be another one. Autumn.
The rectangle.
Okay. Okay, why is the rectangle? Well, because it has four sides, but it does not have two pairs of congruent adjacent sides. Yeah, these sides right here, take a look. That's right, Sierra. I'm seeing it in the chat. It has to be only the rhombus. So Sierra, tell me which one I'm going to drag and drop.
It's down in the left corner.
This one?
Yes.
Okay.
The parallelogram.
Very nice. All right. And Jacob knew it too. Perfect. All right, guys. So we have, let's see if we have one more quest. Okay, this will be our last one for quadrilaterals. One more game, and then we'll move on. So this has to have 4 sides. Opposite sides are congruent. Opposite sides are parallel. And all angles are right angles. Lucas.
Rectangle.
Okay. Very nice. Nicholas.
The diamond.
Yes. Autumn, tell me one more.
The square?
Yes. You did it. Cool. All right. That was pretty fun, guys. We did really good on that. All right. Are there any questions on quadrilaterals? That was good. We did a little review and then we were able to apply it. So that was fun. All right. So congruent figures, pretty easy, I would say. What is a congruent figure? Who can put it into words for me? Go ahead, Nicholas.
It's a side. It's a shape with It's a shape with sides
With the exact same...
length.
That's right. It's the exact, I know what you're trying to say. It's the exact same sides, the exact same angles, and size. So here's an example right here. We're just looking at it on my screen. I could make this triangle face a different way, or I could put it upside down, but I wouldn't be changing the angles or the size of it, so it is still congruent. Let's take a look at some more congruent shapes. So congruent circles, the exact same. Congruent quadrilaterals, they're the exact same. Here's some congruent rectangles and so forth. So congruent is pretty easy, right? It means just exact same size, angles, everything. Similar, yeah, similar is a little different. So we have a guest teacher called, it's Moby and Tim.
But wait, Moby does. If he was our teacher, then we would just be staring at him like he was speaking gibberish because he does. He just goes,
That's true. That's true. So we'll listen to Tim a little bit more than Moby here, but they are going to give us a little rundown on similar shapes, if it ever takes me to the login page. While we're waiting, anybody have any fun Valentine's Day plans?
No.
No. Oh, come on, brain pop. I'm not very patient, And so Jacob forgot to get his mom something. So, Jacob, why don't you just make her a card as soon as we're done here? Even if you just like make her one online and send it to her or something. Okay. And all right. Okay. Sorry for the delay. I always forget how long this takes to log in when it kicks me off. Come on. So maybe we should watch the Brain Pop video on the heart. That was actually part of your 5th grade assignments this week, right? For health? Yeah. Lucas, do you have a question?
No, you asked us what we were going to do for Valentine's.
Oh, good. Let me know. What are you going to do?
Dinner. We're going to out for dinner.
Oh, fun. Where are you guys going to go?
I don't actually remember where we're going at this moment.
I'm sure it'll be busy, but it'll be a lot of fun.
Yeah.
We are actually going to do fondue. We got a fondue maker for our wedding like 4 years ago, and we've never used it. So,
What's fondue?
fondue is like melted cheese.
Very cheap, man.
Yeah, melted cheese, and dip like bread and meat and stuff in it, and yeah,
Cool.
yeah.
Well, for me, on Valentine's Day, I'm getting braces.
Oh, wow, that's gonna be fun.
Yeah, and my sister's getting hers off.
Oh, that's kind of
Maybe.
neat. Cool. Well, good luck with that, Sierra. Yeah. Okay, so sorry that.
As a present, getting braces.
And
They're
also,
really hard at first, but then you'll get used to them, I promise.
I've
done
had
it
them
before.
before. Yeah, I have too. I hate them.
We watched the one on Pi because Pi is totally awesome. I mean, not as cool as the Golden Ratio, but it's totally awesome.
I can't even wear my retainer I'm supposed to wear just because of my 12-year molars,
Oh, bummer.
which is the win for me right now.
Yeah, you guys, a lot of you have braces. I am sorry this is taking so long.
Ratio.
No! Oh, there it is. There it is. Okay, sorry. We're finally ready. But it's okay. It's Valentine's Day. We had to do a little talking anyway, like we would in a normal classroom about, fun Valentine's Day type stuff. So, but now our guest teachers are finally ready, and here they are to present something on similar figures. Yay!
You'll never make it, Captain Evil.
Yes, I will.
Told you you wouldn't make it.
Oh,
Dear Tim and Moby, can you help me on using similar figures? Thanks, Chase Dixon. Sure thing, Chase. In everyday conversation, the word similar is just another way of describing things that are alike. But in math, it has a more specific meaning. Figures are geometrically similar if they have the same shape, but not necessarily the same size. Nope, it doesn't mean that all triangles are similar. Triangles can have very different shapes. Take the triangle on Captain Evil's chest. His triangle of evil. Sorry. Okay, as you can see, it's an equilateral triangle, which means it has 3 sides of equal length and 3 60-degree angles. So now, check out this wooden block, which is also triangular. This is a scalene triangle with sides of different lengths and 3 different angles. Geometrically similar triangles have to have corresponding angles that are congruent or equal. These don't. And
yeah, I was just going to say, so those two examples right there, even though they're both called triangles, they are completely different.
Similar triangles have to have corresponding angles that are congruent or equal. These don't.
Nope.
And they would have to have corresponding sides that are all proportional in length. And that means that the relative lengths of the sides would have to be the same. Our equilateral triangle has sides of lengths 2 centimeters, 2 centimeters, and 2 centimeters. Since they're all the same, we can reduce that ratio to 1 to 1 to 1. The scalene triangle has sides of 6 centimeters, 8 centimeters, and 10 centimeters. We can reduce those numbers by dividing by 2 to make the relative sizes 3, 4, and 5. The sides are obviously not in the same proportion, but the angles are all different. So these triangles are not similar. Good idea. Let's compare Captain Evil's triangle with the triangle formed by the ground and our swing set's legs. The angles of this big triangle are all 60 degrees, just like the triangle of evil. And since the sides are all the same length, they form the same ratio with the corresponding sides of the smaller triangle. So they're officially similar. Right, even though the swing set triangle is much bigger than the triangle of evil, the corresponding sides have the same proportions. If we want to find out the size difference between the two triangles, we can use something called scale factor. To find the scale factor between two similar geometric shapes, you just simplify the ratio between any two corresponding measurements, not including angles. Let's use two sides from our triangles. The ratio is 4 meters to 2 centimeters. The big triangle is 200 times bigger than the small one. By the way, this applies to all kinds of shapes, not just triangles. Well, all squares are similar by definition, since they all have 4 equal sides and 4 90-degree angles. The same goes with circles. You can read more about that in our features. But other shapes you do have to measure out. Sure, there's plenty of things you can do with similar figures. One is called indirect measurement. That's a way to measure things that are way too big to measure directly, like how tall that tree is. See how the tree casts a shadow to make a triangle? Well, we can use a meter stick to create a similar shadow and triangle. We already know the length of the meter stick, 1 meter, and we can measure the length of both shadow lines on the ground. Now we make a ratio for the lengths we know and solve for x. The tree's 8 meters tall. Which is exactly how far Agent Awesome can toss your puny Captain Evil if he's dumb enough to... Hey!
All right. All right, guys. Now it's time for a little practice. Let's take the quiz. So I think most of these are multiple choice, so you'll be able to type like an A, B, or C or whatever into the chat. Okay. Similar figures. So same proportions, not same size. Same shape. Wow, BrainPop's running kind of slow today. Or maybe it's just my computer. Who knows?
I can try on my computer.
Well, let's give it just one more second, because pretty much any time I give up, that's when it'll come up. Oh boy. All right. Well, there it is.
Ooh.
Yeah. Whew, loading the graphics. Okay.
Yay.
So what did you notice? There was a really important part that you needed to pick up from similar figures. Similar figures are not the same size. They are the same shape. And then how do you know if it's a similar figure? How can you test it? Nicholas?
If they have the same measurement of degrees, like a square always has 360, and another square has 360 still.
Oh.
You could look and see if they have the same measurement of degrees, and then.
Okay, that was definitely one way to check, was to check the measurement of the angles inside of whatever shape it is. So if the angles are the same measurement, that is definitely one way. And then, did you notice that word that started with a P called proportion? They have to have the same proportions. So if one side is 2 and the other side is 2 and another side is 2, like on that triangle, that proportion is 1 to 1 to 1. So anything that can be 300 times bigger, as long as the proportion is 1 to 1 to 1, it will be a similar figure with the same angles, of course. All right, so this is taking a while. We'll come back to that. That's annoying me. Okay. Let's do just a couple practices on this, and then we'll move on. All right. So select all of the objects that are similar to this green rectangle on the top. So let's just type in, we can use A, B, C, and D. Ooh. Okay, so I'm getting a couple people saying both B and D. So let's take a look.
Unless it does color, then.
No, it's not talking about color. Just, yeah, so that we were correct. Okay, how are these two figures related? Are they congruent? Are they similar but not congruent?
Similar.
Or are they neither?
Similar.
Okay, very good. They are similar but not congruent. Okay, now we're looking for exactly congruent. So which figures are exactly congruent to this blue square?
Can you scroll up so I can see the blue square?
Look closely. Remember, it does not matter which way they're kind of facing. All that matters for congruent is that they are the exact same size, same shape, and same angles. Go ahead, Sierra.
D.
Is that the only one?
C. I think it's
If
the C.
and C, not C, and maybe B if I could.
And I think it's actually A as well. Yep, you're right, Autumn.
Oh,
It's all of them. They were just tilted a little differently. Okay, now this is pretty easy. These two figures are similar. So remember, similar figures have the same angle measurements. So if this is 106 degrees, what does this angle have to measure as well? Nicholas?
106.
106. That's right.
106.
Perfect. Okay, so last one for this practice. Select all of the objects that are similar to this one. Lucas, which one is it?
It's C. I mean B.
B, that's correct. And that's exactly what everybody in the chat had said. You guys got it. That was pretty easy. You guys are little wizards on congruent and similar figures. Let's move on to something a little harder, transformations.
Wait, maybe we can check on Brain Pop.
Yeah, we could go back to Brain Pop and see if it's ready yet, too. Nope, it's not. Look, still loading. Oh. I lied. It is ready. Okay, let's do the quiz really quickly, and then we'll move on to our transformations.
Make it big screen.
Yes, I will. Okay, there we go. When are two geometric shapes considered similar? Okay. Let's go ahead and read through your choices. Very nice. Everybody in the chat has told me B.
B. B.
All blank triangles are similar. Now remember, scaling triangles are completely different. They have all different sides, all different angles. Right triangles have one right angle. Isosceles triangles have two similar sides. Equilateral has all similar sides. So yes, go ahead, Lucas.
A.
That's right. It has to be A. Good. Yes, Jacob, that's fine. A triangle has sides of 3, 6, and 9. So which triangle has sides that are in the same proportion? So let's reduce 3, 6, and 9. Let's divide each of them by 3. So it could be 1, 2, 3. So which one of these triangles has the proportions of a 1, 2, and 3? Okay. So let's look at this one. If I divide 13 by 13, I'd get 1. But if I divide 16 by 13, I do not get the proportion of 2. Look at triangle B. If I divide 9, that's right, everybody's saying B. If I divide 9 by 9, I get 1. If I divide 18 by 9, I get 2. And then 27 by 9, I would get 3. So there is my proportion of 1, 2, 3. Good. A triangle has sides of 4, 12, and 16. This ratio can be reduced to, so divide all of those numbers by 4.
I can't read the question for some reason.
A triangle has sides of 4, 12, and 16. The ratio can be reduced to, so if I divide by 4, I get 1. 12 by 4, I get 3. And then 16 by 4, I'd get 4. So the proportions can be reduced to 1 to 3 to 4. Okay? You have two similar equilateral triangles. One has sides that measure 8 meters each. The other has sides of 40 centimeters each. What is the scale factor? So in other words, how much bigger is this second triangle? Oh, wow, and they're talking about meters too. So we got to convert the meters into centimeters. First of all, how many centimeters are in 1 meter? Nicholas?
100.
That's right. So there would be 100 times 8. So this would be 80 centimeters. I'm sorry, 800 centimeters. Woohoo! 800 centimeters. And the second triangle only has 40 centimeters. So I can...
That's
So,
weird.
yeah, well, how much bigger is this first triangle? Let me draw the picture. Well, I'll try to draw a picture. I'm not very good at drawing, but we'll get there. Okay, so here's our first triangle. Here's our second triangle. And it's not great, but you get the point. Okay, so this side is 800 centimeters. And this side, so I'm looking at these similar sides, is only 40 centimeters. So how much bigger is this triangle than this triangle? It's a division problem, right? Okay, Autumn, go for it. What do you think?
I think it's 200.
Well, is 40 times 200 going to give me 800?
Oh, multiplication.
Oh no. I think it's actually 20.
Okay, I think so too. So when you are working with numbers like this that both have similar zeros, I can just get rid of those and make my division problem easier. 80 divided by 4, do you think it's 20?
Yes.
Okay. All right, so then going back to it, it is 20 to 1. It's 20 times bigger. Very good. A square has a side of 5 centimeters each. Which square is similar? Ooh, trick question. What do we know about squares?
They're all similar.
They're all similar. Very good. So, because they all have 4 90-degree angles and so forth. Good. What must you do in order to determine whether two rectangles are similar? Do you need to measure the interior angles of the rectangles? Or do you need to measure the sides of each rectangle to see if they're proportional? Do you have to look at the scale between the two rectangles? Or do you have to divide the length of each side of the smaller rectangle by the length of each side of the larger rectangle? Well, in a rectangle, we're not going to have to, and we're looking at two rectangles, we know that their angles are going to be the same. So the only thing that would make sense to do is to look at the proportion size, okay, to see if they are proportional. All right. A tree casts a shadow of 3 meters, while a meter stick casts a shadow of 0.75 meters. How tall is the tree? Ooh, this one's kind of tough. So this is another, this is kind of a little bit of algebra for us here.
Wait, hold on. What a meter stick? That has nothing to do with it.
Well, it kind of does. What they're asking us for are similar. I'm going to wipe this clean here. We're looking at similar figures. So we have. Here's what we know. This tree casts a shadow of 3 meters, while the little stick only casts a shadow of 0.75 meters. But if you go back to the picture, you can see that they're both similar. See how they're the similar angles and all that kind of thing. So if we take what we know, oh gosh, get back to my other screen, sorry. We need to just basically see how much bigger is this than this. Okay, so what would I do to 0.75 to end up with 3? Well, what if I just experimented and started adding up
No, you just
0.75?
need to add 2.25.
What?
2.25.
Sorry, Nicholas, say that again.
You need to add 2.25 to 0.75 to get 3.
That's right. So would you say that maybe it's about 4 times bigger? Because look, that's exactly what I did is I just broke this number up and then I'm adding it all up. And it would be about 4 meters, right? Because it's about 4 times bigger. That one's kind of confusing, but it was okay.
I don't get what the measuring stick has anything, why it would be able to measure the height of the tree.
Well, it was just because it was a similar figure and it's similar. Basically, we just had to find out how much bigger the tree line or shadow was than the yardstick shadow. So, how much bigger is this number than this number?
Okay.
The short side of the rectangle is 6 centimeters and the long side is 21 centimeters. Which of the following rectangles is similar? Okay, so we're looking for something that is similar here, and we have the proportion of one side is 6 and the long side is 21. So let's look. Well, this one, I can't really do anything to 21 to end up with a 10, so I'm not thinking that's probably it. Ooh, I'm seeing a lot of people say D. Yes, if I divide both of these numbers by 3, I would end up with a 2 and a 7, and I think that that's exactly correct. A rectangle has a side of 72 centimeters and 36 centimeters. Another rectangle has sides of 4 and 8. What is the scale ratio? So here again, we are finding out how much bigger this other rectangle is. So let me draw the pictures. All right, here's our big rectangle. Oh, geez. Well, whatever. Here's our small rectangle. And they said, what was it, 36, and what was the other one, 70? Go back. 72. Okay.
Those are good numbers.
Yeah. And then this one is 4 and 8. All right, so let's look at how all of these numbers are related. Just think in your mind, what do I do to a 4 to end up with 36? Multiply it by 9, right? What if I multiplied 8 by 9? Do I end up with 72? I do. So how much bigger is this rectangle? It should be 9 times bigger. So here is our proportion, 9 to 1. Yay!
Can we view our results?
Yes, and we got all of them correct. I pretty much figured that we did. All right. You guys did great. Thank you for helping me on that. Oh my goodness.
View your answers.
We're like out of time, guys. I can't believe this. Oh no. Okay. It's all right because we have a math VC next Thursday and we will pick up with transformations. Really fun stuff. I don't want to get into something as in-depth as transformations when we have 1 minute left. So don't worry, we will get there. If you want to, you can, because I have sent you this agenda. It is in your email. You can go and click on these 2 different lessons right now. One is Brain Pop again, and then the other one is our kind of weird friends. I don't even know their names.
Something.
Right. So here is the deal. Monday is President's Day, so we do not have a virtual classroom on Monday. I will see you next Thursday for a math virtual classroom. But then, what is special about February 25th? What are we going to be doing that Monday? So not next Monday, but the one after. Nicholas.
Book club.
We are going to be doing our book club, and what are you going to be presenting?
Your 30-second movie.
Your 30-second movie. Has everybody been able to get into Edmodo and start looking at your folders of your book? Maybe start adding.
I haven't started yet.
Okay, well, it's okay. Lucas, do you have a question?
I haven't started yet either. I didn't really get it with the code. It wanted me to sign in or something.
Well, yeah, you have to create an account. Think of it like Facebook, Edmodo. So you have to create your own login, like for you to log in, and then you have to type in the code that it gave you. So the code that it's 94FX LL. So after you create your account, that's the code that you'll type in, and then it will take you to our group. Okay?
Okay, I'll sign up with my dad.
Yeah, that'll be great. And then add to your folders, find more images. I gave you guys like 10 images, but I would love to see like 100 images. If we all added a couple, we could definitely get there. And then that would make our movies in Adamoto much different, if we had that many images to choose from. So, all right. And Jacob says, yes, he is in Edmodo a lot. Are you enjoying it, Jacob? Yes, he is. Okay, perfect. All right, guys, happy Valentine's Day. I will see you next Thursday, okay? Have a great
Bye.
weekend. Bye.